In these problems 55 to 62, they are exercising your ability to differentiate using notation and then being able to use that table to be able to evaluate these expressions. So I have a function a, which is a combination of function f plus 2 times function g. So we don't really know what f and g are, but we know some of the output values of f, and we know some of the slopes at those output values, and we know some of the output values of g, and we know the slopes at those values. So to differentiate this, we need to differentiate this using the notation. So a is equal to f plus 2g. So a prime must be equal to f prime plus, well, the 2 doesn't affect my derivative, so 2 times g prime. And if that's the case, then if I want to evaluate the derivative at x equals 3, I need the f prime at 3 plus 2 times the g prime at 3. Well, I can go to my table for that. F prime at 3, f prime at x equals 3 is equal to 4. So that's going to be equal to 4 plus 2 times g prime. There's my g prime. At x equals 3, g prime is equal to negative 1. So then my derivative is equal to 2. So my slope is 2 at x equals 3 for that a function. So the same thing can be done here. We want the derivative and evaluate the derivative at x equals 2. To find the derivative, I take my f times g function. Well, that is a product, so I need to apply product rule. So it'll be f prime g plus f times g prime. There's my product rule. And if I want to find b prime at 2, I need f prime at 2 times g at 2 plus f at 2 times g prime at 2. Okay, let's make sure that's a prime. And then again, we go back to our table here. I need f prime at 2. F prime at x equals 2 is 3. So that's going to be equal to 3. G at 2, not g prime, but g at x equals 2 is going to be 1. So I need these, basically I need these values here. At x equals 2, I need f prime, g prime. So g at 2 was equal to 1 plus f at 2 was equal to, I can't read that there, 5, and g prime was negative 2. So times 5 times negative 2, this becomes 3 minus 10, that's equal to negative 7. So the answer is B.